All right, folks, this is where it starts getting interesting. We're going to learn about a formula, two formulas actually, that deal with the area of regular polygons. So let's get on with it. The first formula we're going to develop is a formula for us to calculate the area of an equilateral or equiangular triangle. So here's an example where we have an equilateral triangle. We don't know what the side length is, so we're just going to generalize it and call it S. So if we were to actually go about solving this in general, because it's a triangle, we're going to need to drop down the altitude. So we would pull in or drop in the altitude down to the base, and we know that that's going to be perpendicular. And what that does is it splits it into two right triangles. The other piece of information that we do know is that each of the angles in an equilateral triangle are going to be 60 degrees. So this angle right here is 60. And by extension, that means that this angle up here is going to be 30. So there's two ways to think about what the length of this side of the little right triangle is. Either you remember that when you drop down the altitude, it's going to split this base in half, or looking at your 30, 60, 90 triangle, S is the hypotenuse, and this is the side opposite 30. So this little side is half of the hypotenuse. So either way that you want to think about it, we know that this is S over 2, or half of S. Once we have this value, to figure out this side that's opposite the 60 degrees, recall you take this number and multiply by the square root of 3. So that's going to be S root 3 over 2. All right, so once we have those values all taken care of, if we use our traditional area formula for the triangle, 1/2 base times height, we can plug it in. Here's the 1/2. The base is this entire thing. Remember, it's not just S over 2, but it's the entire S, multiplied by the height, which is S root 3 over 2. So we get this expression right here that we can simplify to make our formula. So this S and that S can multiply together to be S squared. This 2 and that 2 can multiply together to be 4. And there you have it. That is your formula to figure out the area of an equilateral triangle. All you need to know is what the side length is. So for example, if I said you have an equilateral triangle whose side length is 5, you don't have to go through this whole process anymore. You just have to say, oh, I plug 5 in here, 5 squared is 25, so it's 25 root 3 over 4, and you're done. So this is a really nice formula. I bet you wish you had this on your quiz that you took today, huh? Okay, well, you didn't, so moving on. All right, so now what we want to do is we want to have a formula to use in any regular polygon. And I drew a pentagon here just for demonstration purposes, but this will work for any number of sides in your regular polygon. And so I've put a circle that is circumscribed about the pentagon because we're going to talk about the radius and apothem in relation to the polygon. But if you think about the radius of the polygon is actually this segment going from the center of the polygon to one of the vertices. And we call it a radius because those vertices are on the circle, right? So this actually is the radius of a circle that is circumscribed about the polygon, but that's the radius of the polygon as well. The apothem, that is created by dropping down a segment from the center to the midpoint of one of the sides. So it would look like that. Okay. Now if you think back to chapter 10, this segment, which if we extended it all the way to the edge of the circle there, would be the radius, and it is intersecting the chord, okay, and it's bisecting the chord. That means it's going to be perpendicular to the chord as well. So what do we know about an apothem? Well, you only find these things in regular polygons. It joins the center to the midpoint of each side, or any side. So I can draw, in this case, I can draw 5 apothems if I really wanted to. I only need 1, but I could. And then all apothems of the same or congruent regular polygons are going to be congruent. So it doesn't matter if I drew it to this side or to that side, it's all going to have the same length. The other thing that we should know is that the radii, these are going to bisect the angle that it's drawn to. So if you know what the measure of an interior angle of a polygon is, when you draw in the radius, you just cut that angle in half and you get this little angle right here. Because notice what's created. We have a right triangle. And we can use any and all of our right triangle methods to figure out missing sides. Okay? And sometimes it is a matter of knowing what this angle is and having to use some trig. All right? So lots of problem solving, having to figure out the best way to go about solving your problem. Okay, so here is the formula to figure out the area of a regular polygon. It is 1/2 the apothem times the perimeter of the polygon. Okay, so 1/2 apothem times perimeter. So depending on what they give you, maybe they give you the perimeter already and you have to calculate the apothem. Maybe they give you the apothem and you have to figure out the perimeter. But perhaps they might even be really evil and give you the radius. And then you have to calculate both apothem and perimeter. Wouldn't that be fun? Just stuff to look forward to, right? Okay, so here's an example. It says find the area of the regular hexagon if the apothem is 6. So let's go ahead and draw in the apothem. We know it's 6. The next thing that we would have to do is to draw in the radius. And you can draw the radius either to this vertex or to that vertex, but we only want to draw it to one vertex so that we get a right triangle. So I'll go ahead and draw that in. The next thing we're going to want to do is, we already know that this is a right angle, so we're going to want to figure out what this angle is right here. So if you go back to chapter 7, which you might have to pull out your notes and take a look at, there's a formula to figure out a specific angle, specific interior angle of a regular polygon. And I'm not going to tell you what that is. You can go back and look up those notes. Okay, but you're going to have to figure out what that is depending on your shape, how many sides you have, plug that into your formula, figure it out, cut it in half, and then you get this angle. So I'll just tell you, in a regular hexagon, each of these angles is 120 degrees. So that means that this angle right here is 60. So notice what that creates for us. It creates another 30, 60, 90 triangle. Okay, so this side, which is 6, is opposite the 60. So that means that 6 is equal to the x root 3. And now we can solve for x and we get 2 root 3. Well, this x that we solve for is this length right here of this little right triangle. So that's just this part right there. But you can imagine how this would help us because we need to know the side length in order to figure out the perimeter. So this is just half of the side length. So each side length is going to have a value of 4 root 3, just multiply by 2. And once we have that, then we can figure out the perimeter of our hexagon, which is, there's 6 sides, so 6 times 4 root 3, we get 24 root 3. Now with this information, we have the apothem, we have the perimeter, we can use our formula up here, plug it all in, and we end up getting 72 root 3 units squared. Okay, so it's not too bad. There's definitely more work involved with these questions. All right, let's try another one. Find the area of a square whose apothem is 6. So that's kind of weird because usually with a square, they give us the side lengths, which are the same, and we just multiply them together, right? Well, in this case, they're telling us what the apothem is, and we're not used to dealing with that in a square. So think about the definition of an apothem. It's going to start from the center of the circle, or I'm sorry, center of the polygon, and it's going to drop down to the midpoint of one of the sides. So in that case, this right here is going to be the apothem, and that is given to us as being 6. Well, this is a square, right? And we're going from the center of the square to the midpoint of this side. Well, that means that if we went up as well, we could have gone from here up there. That's also 6, so you can figure out that the whole side length is going to be 12, and therefore the area is 144 square units. So you didn't have to draw in triangles in this case to figure it out. We could have drawn this in 45, 45, 90 triangle, figure out this is 6, that's 6, you get the idea. Anyway, there you have it. There's your new formula. It's really depending on what polygon you're given, how many sides it has. It's going to be a different process to be solving for either the apothem or the perimeter or the side length or whatever it is that you need. Okay, so Happy calculating.